So we have Ethan's video. I think it should be playing next.
Hello, my name is Ethan Fay, and I'm a Senior Solutions Architect at Amazon Web Services, or AWS. Today, I'm going to show you an example calculation run from a Jupyter notebook using the CMIP6 dataset. And this calculation will be parallelized across a Dask compute cluster to make it go faster. So CMIP6 stands for Coupled Model Intercomparison Project version 6, and it contains the model output from a number of climate models with the intent of allowing researchers to compare the results between these models. The CMIP6 data is hosted on AWS as part of the AWS Open Data Program, and anyone is free to access this data, along with many other geospatial and climate datasets that may be of interest. The CMIP6 data that we'll look at today is in Zarr file format, and it's hosted on Amazon's S3 object storage service. To make my calculations run faster, I will be using a combination of Xarray and Dask to distribute my computations across many CPU cores spread out across a number of underlying Amazon EC2 compute instances. To save on cost, I will show you how my setup automatically instantiates new EC2 compute instances when I request a compute cluster from my Jupyter notebook, and automatically terminates those instances when I'm done. I only pay for the compute resources that I need when I need them. Because I only have a few minutes today, I'll show you everything very quickly, but note that you can recreate everything I show you today on your own AWS account using the detailed instructions that I have on GitHub. And I'll have that URL for you at the end of the presentation. Here is the Jupyter notebook that we'll use to run our calculations. After importing the required Python libraries, the first step is to create what's called a Dask cluster. Right from my Jupyter notebook, I can select how many CPU cores I would like for my cluster, and then run this code block to create my cluster. Under the hood, a number of Dask worker Docker containers have been scheduled onto my Amazon EKS Kubernetes cluster. I have an EKS cluster autoscaler configured, which in turn automatically instantiates additional EC2 instances if there are not enough available for the scheduled containers to fit on. If you do have enough EC2 instances already, the cluster creation takes only a few seconds. To save on cost, I typically do not have these EC2 instances on all the time, so it can take a few minutes for everything to spin up and become available. Now that some EC2 instances have been created, I have a Dask compute cluster with 52 cores and 171 gigabytes of RAM so far. Note that I also opened the Dask web interface, which we'll look at soon. In these next few code blocks, I'm using the Python library Xarray to create a dataset object that points to Zarr data from the CMIP6 S3 bucket. If we inspect this section of the dataset, we can see that it's around 6.5 gigabytes in size. It has 31,390 time steps worth of 180 by 288 grids of air temperature at 2 meters and air pressure at mean sea level. After converting the air temperature from Kelvin to Fahrenheit, let's do an example calculation by taking the mean air temperature across all 31,390 time steps of this dataset. Because we're using Xarray and Dask, this calculation can be parallelized and run across all of our Dask worker nodes in our cluster. We can see how Dask created and executes its task graph by looking at the Dask web interface. Each colored block you see here represents a piece of the overall calculation performed on an individual worker node. As the mean calculations progress, the results are aggregated back together to create the final grid of mean values. This calculation ended up taking 27 seconds, and it takes significantly longer when run on only a single CPU core. For even larger computations against larger datasets, it becomes increasingly important to leverage this type of system to parallelize the computations. With the calculations complete, we can now shut down the cluster, which in turn terminates all of the underlying EC2 compute instances, saving on cost. That's it for our demonstration today. The key takeaways are, first, AWS's Open Data Program hosts many geospatial and climate datasets that you can access, including CMIP6. Second, using Xarray and Dask running on cloud infrastructure like Amazon EKS allows you to scale out to get your research questions and calculations completed quickly, but it also scales back in to save on costs because you only pay for what you use on the cloud. Third, Zarr is an n-dimensional cloud streamable file format ideally suited for large n-dimensional climate datasets. And you can find examples of Zarr datasets on the AWS Open Data Program, along with example blogs and notebooks to help you get started. If you're interested in a detailed walkthrough on how to recreate what you saw today, please check out this URL on GitHub. And with that, thanks everyone for your time and attention. Please don't hesitate to reach out if you have any questions or feedback.
All right. Thank you, Ethan, for the talk. And Ethan, you can ask questions to Ethan on the Gitter channel. He's already over there.